Okay, so we're going to talk a little bit about graphing rational functions and how to tell different things from the equation that you were given. So first thing, let's just talk about some transformations. So the parent graph of a rational function is 1 over x. So what I want to do is I just want to take a look at the picture of that. So let's graph 1 over x. All right, so if you look at that, this is what a rational function looks like. All right, and as you can tell, it's approaching 0 right here, so we have a horizontal asymptote right here. And it's approaching 0 here, so we have a vertical asymptote right here at 0. All right, so what we're going to talk about for just a minute is how changing different parts of this will affect your graph. So for instance, let's say that I change just the denominator down here to x minus 3. So what I want to do is I'm going to go back here, and in my y2 I'm going to graph 1 over x minus 3. And I want you to see what happens here. So if you look, it moved. It was here, and now it moved over here. And if you look, it moved 1, 2, 3 spaces to the right. So if you take a look at this equation that you have a 3 right here. Now it says minus, so you're going to actually think about it as opposite. So this was translated 3 units right. So if it's minus 3, that means it will move 3 right. So if it was a positive 3, it would be moving 3 left. All right, let's talk about this. I didn't change the bottom, but I did change and put a number out here. So let's see what that did. So let's take out this bottom one, and let's do 1 over x, and then minus 2. Take a look at that. So here's my first one, my parent graph. Now this one is the same, except now it moved down, and it moved down 2. So what we can infer from this is that if you subtract 2 on the outside, that's going to translate it two units down. So changing the denominator moves your asymptote 3 units right, and this moves your horizontal asymptote up or down. So if it's minus 2, it moves down 2. If it's plus 2, it would move up 2. So it does exactly what it looks like. So here I've added 4 to the x underneath. So that means it's going to translate 4 units. Looks like it would go right, but really it's going to go left. And if you look at number 4 here, I'm not changing the denominator. I'm just changing this number out to the right. And it's plus 1, so that means it's going to translate 1 unit up. So that kind of tells you a little bit about the different parts. Okay? So now let's get into where we're actually going to graph some of these. And I've made a list for you, okay, so that you can uh, see what this is. So I'll give you a second. You may want to pause that and try to write it down. All right, just some steps. All right, you can pause at any point. Make sure you get all of those written down. And then there's this bottom part. All right, so when we are graphing these, what we're going to do is, first off, if we can factor the numerator or the denominator or both, then we're going to do that. And then we're going to check to see if they have any common factors. If they don't, then we compare the degrees of our numerator and denominator, and that's going to determine our horizontal asymptote. All right. Then we're going to use our factor denominator to determine our vertical asymptote, our factor numerator to determine our zeros or our x-intercepts. You might want to write x-intercepts there. And then we'll graph it. If they do have common factors, then we're going to use that common factor to identify any holes there are in the graph. And then after that, you can proceed to step 4 up here and then continue on until you graph. I'll probably graph along the way. You can graph at the end if you want to. I like to do it all at once. All right, so I'm going to add a page here so we can talk about a couple things. All right, so here are the rules about horizontal asymptotes. So you've got P and Q, that's just something on top, something on bottom. All right? And it says their functions in standard form with no common factors other than 1. So the graph has at most one horizontal asymptote. So if the degree of the top is bigger than the degree of the bottom, then you don't have a horizontal asymptote. Okay? If the degree of the top is smaller than the degree of the bottom, then your horizontal asymptote is y equals 0. If the degree of the top is the same as the degree of the bottom, then you're going to take the leading coefficient of the top and divide it by the leading coefficient of the bottom, and it's y equals whatever you get for that. Okay? So let's give this a little bit of practice. So this is a heading. You're going to want to have some graph paper or draw some graph paper. Okay? To do these. Oh, my thing went away. There it goes. All right. So we're going to identify possible holes, vertical asymptotes, horizontal asymptotes, x-intercepts, and then we are going to graph it. All right, so let's take a look here. Number 5. So the very first step is that we are to factor the numerator and the denominator. So step number 1, we're going to factor the numerator and denominator if possible. So I'm looking at this, and I see that I have a trinomial. So I'm going to try to factor that. I've got a minus in the back, so that tells me I have a plus and a minus, x and an x. And two numbers that multiply to make 3 and subtract to make 2. That would be 3 and 1. 3 goes with the minus. And then on the bottom, I just have x minus 2. I can't factor that. So I'm going to look to see if I have any common factors that I can cancel out. I see that I do not. I have an x plus 1, an x minus 3, and x minus 2, so I can't cancel any of that out. So I'll move on to step 3. Okay, so step 2, no, there are none. All right, step 3. We're going to compare the degrees of the numerator and the denominator. All right. Now, oh, something I want to mention. Step 2 is all about the holes. So why don't we do this instead? We're just going to say, are there any holes? Because that's what that is. There are none. No holes in our graph. All right, step 3, we're going to compare the degrees of our numerator and denominator to determine our horizontal asymptote. So remember, you may want to refer back to these right here. All right, so let's take a look. The degree of the top is 2, and the degree of the bottom is 1. And remember, it's the highest degree you have. So like I have a degree of 2, 1, and 0. So the degree of that whole polynomial is 2. And the degree of the bottom is 1. They should already be in order, okay, standard form. So that should be easy for you to tell the degree. So the degree of the top is bigger than the degree of the bottom. So let's check our rules here. So if the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. So we'll just call that the HA, horizontal asymptote, none. Okay? So I have no horizontal asymptote. All right. So now step 4. We're going to use our factored numerator, or denominator, to determine our vertical asymptotes. Well, we only have one thing in the denominator, so what we do is we set that equal to 0, and we solve for x. So I just add the 2. X equals 2 is my vertical asymptote. Yes, you must say x equals 2. All right, step 5. I'm going to use my factored numerator to determine my zeros. I'm just going to call them x-intercepts. Well, I have two factors in my numerator. I have x plus 1, so I'm going to set that equal to 0. And I have x minus 3, so I'm going to set that equal to 0. So I would subtract 1, so I get x equals negative 1. And I would add the 3, so I get x equals 3. So my two zeros are negative 1 and 3. X-intercepts, zeros, solutions, roots, all the same thing. This is where it crosses the x-axis. So now that I have all of that information, I am going to go up to my graph and I'm going to plot all that. So I don't have any holes. I don't have a horizontal asymptote, but I do have a vertical asymptote at x equals 2. So I'm going to go where x is equal to 2. Ooh, let's do it in blue. Remember, asymptotes are always dotted. So I'm going to go where x is 2, and I have a vertical asymptote there. So I'm going to draw that line in. Remember, extend it all the way through your graph. All right? Now let's look at what other information that I have. Well, I know that I have x-intercepts at negative 1 and 3. So I'm going to go back up to my graph. And I have x-intercepts at negative 1 and x-intercepts at 3. So let's go there. Negative 1, we've got a dot. And 3, we have a dot. So that's where my graph's going to cross. Now, other than that, I really don't have any other information here. So what we're going to do is we're going to use our calculator to kind of help us draw this picture, okay? But anything that you have found has to be on your graph, all right? If it's not, you're going to get points taken off, okay? So let's look here. Go to your y equals. Make sure you take everything out. And we're going to put that equation in. So we have a fraction, x squared minus 2x minus 3 all over x minus 2. And let's graph that. All right, so we see that it crosses at negative 1 and it crosses at 3, but it kind of stops and then picks back up over here on this side. So that's where our asymptote is right there at 2. And I'm not going to be super picky. I'm not going to make you pick points, but I do want a graph that looks really similar to this. So it looks like it's almost a line, and then it starts curving up. Same thing here. So what we're going to do is we're going to pull our stuff up here. So I have a graph that's going to go something like this. And I want you to use, oops, sorry, I'll try to make this look a little better. use your whole graph. Now remember, this is not going to cross this line or touch it. Neither is this one. But as you can see, that looks very similar to that graph right there. Alright, so let's move on to the next one. Number 6. So the very first thing I do is I factor the numerator and denominator if I can. So on the top I have a trinomial. Plus sign and back means 2 of what's in front. And then I just have an x squared. And the two things that multiply to make 6 and add to make 7 are 6 and 1 all over. I cannot factor x plus 3. Step number 2 is all about my wholes. Alright, I have wholes if I have matching factors. So do I have a matching factor between top and bottom? No. So I have no wholes. Alright, step 3 is that I'm going to look and see if I can figure out what my horizontal asymptote is. Well, if I look at my rules here, it says if the top degree is bigger than the bottom degree, then we don't have any horizontal asymptotes. So let's take a look here. Top degree is 2, bottom degree is 1. When the top degree is bigger than the bottom degree, we don't have any horizontal asymptotes. So horizontal asymptotes, we have none. Step 4, I'm going to use my denominator to figure out what my vertical asymptotes are. Well, I only have one factor. I'm going to set it equal to 0 and solve for x. So I have a vertical asymptote at x equals negative 3. Okay? Step 5 is I'm going to find my x-intercepts. And to find those, I use my numerator. So I have 2 factors in my numerator, which means I'm going to have 2 zeros. So I will set both of those equal to 0. So I have to subtract 6. So I get x equals negative 6. Subtract 1. X equals negative 1. So my 2 zeros, or x-intercepts, are negative 6 and negative 1. Now I'm ready to graph. So the only pieces of information that I have are I don't have any holes or horizontal asymptotes. But I do have a vertical asymptote at negative 3. So I'm going to go to x equals negative 3. Extend that all the way across my graph. And then I do know that I have x-intercepts at 2 different numbers. I have one at negative 6, and I have another at negative 1. So I'll go up to my graph, 3, 4, 5, 6, and I have one at negative 1. So again, I don't really know what this graph looks like, so I'm going to go ahead and go and graph it. So my equation is x squared plus 7x x plus 6, and on bottom I've got x plus 3. So let's graph that. So as you can see, it really looks a lot like the last one. We're crossing at negative 1 and negative 6, and I have a horizontal asymptote at negative 3. So we'll draw that in. Make my pen a little less thick. Okay, and there's that graph. Alright. I think I did mess up on my numbering here. This is not number 8, this is number 7. Sorry about that. Alright, so let's take a look here at number 7. Alright, the very first thing I'm going to do is factor top or bottom, or both. So I have a trinomial on top. I'll have plus and a minus, x and x, and 3 and 2 will multiply to make 6 and subtract to make 1. 3 will go with the plus. And then on bottom I have x. So, now I'm looking at this. Step 2 is all about, do I have any holes? Well, in order to have holes, I would have to have a common factor between the top and the bottom, and I do not, so I have no holes. Step 3 is all about my horizontal asymptote. So we're going to compare the degrees of the top and bottom. The degree of your numerator is 2. The degree of the denominator is 1. So since the degree is bigger than the top, bigger on top than it is on bottom, you do not have a horizontal asymptote. So let's talk about vertical asymptotes. We get that from our denominator. So I'm going to set my factored denominator equal to 0. And in this case, it's just x. So x equals 0, not a lot of work to be done there. So I have my vertical asymptote. And then to get my x-intercepts, I'm going to set my numerator factors equal to 0. So I will subtract 3. That gives me x equals negative 3. And I'll add 2. So that gives me x equals 2. So my two x-intercepts are negative 3 and 2. So I don't have any of these to graph, but I do have this vertical asymptote and negative 3 comma 2. So x equals 0 would be right here. I'm going to draw that in. And then I have zeros at negative 3, 3, and positive 2. And again, to get the general sketch of this, I'm going to go to my calculator, and I'm going to graph it. So I get x squared plus x minus 6. On the bottom, I just have x. So as you can see, I cross at negative 3, I cross at 2, and I never cross the 0 right here. So we'll draw this general sketch. Okay, please use your whole graph. It's just harder for me. Alright, now let's move on. Apologize again for the numbering. This right here will be number 8. Ew, that's hideous. 8. There we go. Alright, so let's work this one out. First step is I factor anything that I can. Well, all I have on top is x minus 1. I can't factor x minus 1. And all I have on bottom is x squared, so there's nothing really there to factor. Step 2 is all about holes. In order to have a hole, I would have to have a common factor between top and bottom. The factor on top is x minus 1. The factor on bottom is x squared. That's not common, so we have no holes. Step 3 talks about the horizontal asymptote. So we have to look at our degrees. The degree of your numerator is 1. The degree of your denominator is 2. So the degree on top is smaller than the degree on bottom. And if we reference our rules here, the degree on top is smaller than the degree on the bottom. Then the horizontal asymptote is the line y equals 0. So I do have a horizontal asymptote this time at y equals 0. All right, step 4. It's all about my vertical asymptote. So I'm going to look at my denominator that I have already factored, which I couldn't. I'm going to set that equal to 0. I'd have to square root here. So I get x equals, the square root of 0 is just 0. So I have a vertical asymptote at 0. And then I need to find my x-intercepts. I set my numerator factor equal to 0. This time I just have 1. So I would have to add 1. So x equals 1. So I have a 0 or an x-intercept at 1. So this time I have 3 things to graph. I have a horizontal asymptote at y equals 0, a vertical asymptote at x equals 0, and an x-intercept at 1. So we're going to come up here. I'll start with my horizontal asymptote. It's at 0. So I'll draw my little line here. Asymptotes are important when graphing. Then I have a vertical one at 0. So pretty much just our lines. And then I have a 0 at 1. Alright. Then we have this x-intercept at 1. And this one's a little bit different. Normally we don't ever cross right here. Makes for something interesting. Alright, so now let's go ahead and graph this. Let's look at our calculator and see what we've got in here. So let's take this out. Make sure you're careful when you put these in. Okay. So I have x minus 1 on top and x squared on the bottom. And so let's graph that. Okay. Now this one's a little bit different. It's kind of funky. Since you're not approaching like opposite like we normally are, this is flipped. This is why it crosses right here. But if you'll notice, it crosses and it starts to come down and approach 0 again. So a little bit of a different turn for you there. So this is not going to cross the 0. This one's going to cross but come up and come and start approaching again. So let's draw that in. And again, I'm not expecting something that just looks amazing. Okay? But I do expect something that looks similar and probably better than what I'm drawing. Because let's face it, it's not pretty. So it looks something like that. An interesting example, and that's a really bad looking graph, but you get the gist of it. Alright, number 9, I believe. Alright, number 9. First thing you're going to do, factor if you can factor on the top. So if you notice, and I tell you what, I think I wrote this question down wrong. I did. Let's put a little 2 up here. This is supposed to be squared. Make sure you make that correction. So if you look up here, this is not a trinomial or the difference of 2 squares, but they do have a common factor of 2. So I'm going to factor out a 2. That will leave me with x squared minus 1. On the bottom, I have the difference of two squares. So I know that splits into two binomials, so I'll have x plus 2 and x minus 2. And then I also noticed that on top, this is also the difference of two squares. So let's go ahead and take it a step further and factor that as well. So I'll have x plus 1 and x minus 1 all over x plus 2, x minus 2. So we're going to look at this and determine if we have any holes. So do we have any common factors between the top and the bottom? No. So we have no holes. All right. Step 3, we're going to think about our horizontal asymptote. So we will compare our degrees. So the degree on top is 2, and the degree on bottom is 2. So let's reference our rules here. If the two degrees are equal, then you take your leading coefficient of the top and you divide that by the leading coefficient of the bottom. So we get y equals, the leading coefficient is the number in front of your biggest degree thing, which, let's face it, it should be in the front. So this would be 2 divided by, leading coefficient here would be 1. So we get 2 divided by 1, which is 2. So I have a horizontal asymptote at y equals 2. You're going to look at your denominator for your vertical asymptotes. I have two factors there, so I'll set both of those equal to 0. So I get negative 2 and positive 2. So I have two vertical asymptotes this time. All right, step 5, you're going to find your x-intercepts. You get that from your numerator. So look up here, 2 does not have an x to solve for, so we don't use the 2. You just use the x plus 1 and the x minus 1. So I'm going to set x plus 1 equal to 0 and x minus 1 equal to 0. So that's going to give me negative 1 and positive 1. So I have zeros at negative 1 and positive 1. So I have a lot to graph here. I have a horizontal asymptote. I have two vertical asymptotes. And I have two zeros. So let's go put our asymptotes on the graph first. Y equals 2 is our horizontal. So I'm going to go up to when y is 2 and draw that across. Alright, and then I have vertical asymptotes at negative 2 and positive 2, so I'll go to negative 2, draw in that vertical asymptote. And then I go to positive 2 and draw in the vertical asymptote. And then I have zeros at negative 1 and 1. So negative 1 and 1 is where I'll be crossing. Now this is an interesting looking thing. So to figure out what we've got, let's use our graphing calculator and plug this in. So we've got 2x squared minus 2, and on bottom, x squared minus 4. And we're going to take a look and see what this picture looks like. So as you can see, you have a vertical asymptote here at 2, negative 2. You have a vertical asymptote at 2, and you have a horizontal asymptote right here at 2, 2, 2, 2. And we are crossing at negative 1 and 1. So it's going to be above and running towards your asymptotes on both sides. And this one's going to be kind of a U-shape. Looks like it comes up to about a half. So we've got this side kind of goes like this. And you have this side that kind of goes like this. And then you've got, oops, this that kind of comes up to about a half and then back down. And that's what the graph of that looks like. Let's take a look at number, I believe this is 10. Alright, so the very first thing we're going to do is factor if we can factor. So I noticed that both of these have an x in common. So I could take out an x. That'll leave me with 3x plus 1. And then I notice at the bottom is the difference of two squares. So that's going to give me x plus 3 and x minus 3. Step 2, we're going to look to see if we have any holes. So remember, in order to have a hole, you have to have a common factor between the top and the bottom, and we do not, so no holes. Step 3 is horizontal asymptote. So I compare my degrees. The degree of the top is 2. The degree of the bottom is 2. And when that's the case, it's y equals leading coefficient of the top divided by leading coefficient of the bottom. 3 divided by 1 is 3. Step 4, we're going to look at our vertical asymptotes. So I look at my bottom. I have 2 separate factors, so I'm going to set both of those equal to 0. I'll subtract 3, so I get x equals negative 3, and I will add 3, so I get x equals positive 3. Step 5 is my x-intercepts. So in order to do that, I look up at the factors in my numerator. I have an x and a 3x plus 1. So I set the x equal to 0, and I set the 3x plus 1 equal to 0. I have nothing to solve for here. Over here, I've got to subtract 1 and then divide by the 3. So I get x equals negative 1/3. So my two x-intercepts are 0 and negative 1/3. Now I am ready to graph that. So I have quite a bit to graph. 3 asymptotes and 2 zeros. So I'll go up here. Y equals 3 is my horizontal asymptote. So I'll go up to 3, draw my dotted line. I have a vertical asymptote at negative 3. I have another one at positive 3. And then my 2 zeros are at negative 1/3, so that'd be about right there. It won't be perfect. And also right at 0, so very close. So let's take a look at what this graph will look like. On top, I have 3x squared plus x. Oops, sorry, make sure you get a fraction. 3x squared plus x over x squared minus 9. Okay, so again, it looks a lot like the last one that we just did. I have vertical asymptotes here and here, horizontal one here, and I'm crossing right there. So I'm going to draw that in. Again, I don't expect it to be super perfect, but I do expect it to look a lot like your picture. And there's that graph. All right, number 11. Very first step, I will factor the numerator and denominator. So I have difference of two squares on top. So I'll get x plus 2 and x minus 2 all over x plus 2. Step 2, I want to check for holes. Well, the first thing I'm going to notice is that I have a common factor of x plus 2. So therefore, I am going to cross that out. That's where I have a hole. So set that equal to 0. Solve for x. So you have a hole when x equals negative 2. All right? Now, if you look at what you have left over, you have x minus 2 left over. Okay? So let's go ahead and kind of run through the rest of our motions. Step 3 is that I'm going to look for a horizontal asymptote. So I compare the degrees. I see that the degree of the top was 2, the degree of the bottom was 1. Since the degree is bigger on top than on bottom, you don't have a horizontal asymptote. Step 4, since you have a hole, you don't have a step 4. And I don't think that I wrote that in the thing. Okay, so we don't have an asymptote because we have a hole instead. We don't have a horizontal asymptote, but we can look at our zeros. So let's talk about step 5, x-intercept. The only thing that you haven't marked out is the x minus 2. So let's go ahead and set the x minus 2 equal to 0. So I get x equals 2. So I have a 0 at 2, or an x-intercept at 2. All right, so when you have a hole, you're not going to have that vertical asymptote because there's a hole there instead. All right, let's address this vertical asymptote really fast. My vertical asymptote comes from my denominator, and since I marked out the denominator, there's nothing left. If I would have had an extra factor, then I would have set the extra factor equal to 0, all right, in order to accommodate for the extra asymptote, okay? But if you mark everything out, you're not going to have the vertical asymptote. You'll just have the hole. So if you have an extra factor, you will set that equal to 0. So if you want to put a step 4 right here, you can say vertical asymptote none because all factors canceled. In the bottom. Okay. So let's go up here and graph this. So if you notice, all you have left to graph is x minus 2. That's just a line. Okay. This is just a line, x minus 2. Okay. It has a degree of 1 that's linear. But we can always graph it and see what's going on. So I have a hole at when x is negative 2. So I'm going to graph the whole thing before I put the hole in. Okay? So let's go ahead and put our x-intercept on there. We have an x-intercept at 2. And if I look at this, my slope, since x minus 2 is all I have left, slope is 1 over 1. So from my intercept here, I'll just go up 1 over 1, up 1 over 1, and that just gives me a straight line right through those. Oh, y'all didn't make me change it. It's not dotted, sorry. Okay. Now, oh, I can't do that. I stated I have a hole, so I'm not going to be able to draw it with a line. I'm sorry. Make sure you draw all the way across your paper. All right. Draw your line. And then when x is 2, you have a hole. Well, x is, no, negative 2, I'm sorry. When x is negative 2, you have a hole down here. So this isn't really here. So when it's there, it'll be, bam, you have a hole. Continues on. All right? X is undefined right there. Okay? Let's do a couple more of these. All right, so the first thing I'm going to do is factor the top. So I'll have x plus, x minus, and I'm going to use 2 and 3. 3 will go with the plus. Step 2, I check for any holes that I may have in my graph. I notice that I have a hole right here. X minus 2 cancels. I set that equal to 0. So when x is 2, I'm going to have a hole in my graph. I'm going to check my vertical asymptotes. I have nothing to set equal in the bottom because I've canceled everything out. So I don't have a vertical asymptote. So I'm going to, oh, I did that a step early. Horizontal asymptote. Compare your degrees. It's 2 on top, 1 on bottom. Since its top is bigger than the bottom, you don't have one. And then we've already established for my vertical asymptote that I don't have one of those because I have no denominator anymore. So let's talk about x-intercept. I only have one left in the top, x plus 3, so I'll set that equal to 0. So I have an x-intercept when x is negative 3. So let's go up here and plot that. Negative 3, I have an x-intercept. My slope is 1 over 1. You could just graph that and tell. And then I know that I'm going to have a hole when x is 2. And you guys can have a straight edge, so I'm hoping yours is better than mine. Alright, and then when x is 2, I have a hole right there in my graph. So just erase that little part and put a hole. Alright, and let's go to the last one. And I tell you what, I think that I would like to change this one to something different. So let's change this one. And we'll do x squared plus 3x minus 4 over x squared minus 16. So the first thing I'm going to do is factor numerator and denominator. So I'll have x minus and a plus 4 times 1. We'll multiply to make 4 and subtract to make 3. So this will be 4 and 1. And then on bottom I got x plus 4 and x minus 4. Difference of two squares. Step 2, I'm going to check for wholes. So do I have any common factors? I do. X plus 4. So I'll set that equal to 0. That tells me that I'm going to have a whole at when x is negative 4. So step 3, I'm going to look at my horizontal asymptotes. All right. My degree on top is 2, degree on bottom is 2. When they are the same, I divide their coefficients. So I get 1 divided by 1, which is 1. All right. Then I'm going to check for vertical asymptotes. So far, we haven't had any vertical asymptotes, but if you notice, I do have a factor on bottom that I have not canceled out. So I'll set that one equal to 0. And I will add the 4, so I get x equals 4 as a vertical asymptote. And then I'm going to look at my x-intercepts. So anything I have not crossed out in the top, x minus 1 has not been crossed out. So I'll set that equal to 0. So when I have an x-intercept at 1. So I have a horizontal asymptote, a vertical asymptote, a 0, and a whole all in the same graph. So let's go ahead and plot the things that we do know. Alright, so I have a horizontal asymptote at y equals 1, and a vertical at x equals 4. So y equals 1, x equals 4. Alright, and then I have a 0 at 1, or an x-intercept at 1. And then I'm going to have a hole in my graph after I graph it. So we kind of need to see a picture of this. So I've got x squared plus 3x minus 4 all over x squared minus 16. So it's going to be a different looking graph, and it does not show the hole, just so you know. So it looks like this, but I am going to have a hole over in here, alright, even though my graph doesn't show the hole. So I can see kind of the picture of my graph. So I'm going to go back here, and I'm going to draw it in. So it looks something like, well, if I could draw something like this. It's a terrible looking graph, but you get the picture. And then I have a hole when x is negative 4. So 1, 2, 3, 4. There's going to be a hole right there. So I need to erase, put a hole right there, and show that my graph continues. So there's an example of one where you have vertical asymptote and a hole all at the same time.